Electric power, Wikipedia audio. Electric power is the rate, per unit time, at which electrical energy is transferred by an electric circuit. The SI unit of power is the watt, 1 joule per second. Electric power is usually produced by electric generators, but can also be supplied by sources such as electric batteries. It is usually supplied to businesses and homes by the electric power industry through an electric power grid. Electric power is usually sold by the kilowatt-hour, which is the product of power in kilowatts multiplied by running time in hours. Electric utilities measure power using an electricity meter, which keeps a running total of the electric energy delivered to a customer. Electrical power provides a low-entropy form of energy and can be carried long distances and converted into other forms of energy such as motion, light, or heat with high energy efficiency. Definition: Electric power, like mechanical power, is the rate of doing work, measured in watts, and represented by the letter P. The term wattage is used colloquially to mean electric power in watts. The electric power in watts produced by an electric current I consisting of a charge of Q coulombs every t seconds passing through an electric potential difference of V is. Where passive devices or loads, when electric charges move through a potential difference from a higher to a lower voltage, that is when conventional current moves from the positive terminal to the negative terminal, work is done by the charges on the device. The potential energy of the charges due to the voltage between the terminals is converted to kinetic energy in the device. These devices are called passive components or loads. They consume electric power from the circuit, converting it to other forms of energy such as mechanical work, heat, light, etc. Examples are electrical appliances, such as light bulbs, electric motors, and electric heaters. In alternating current circuits, the direction of the voltage periodically reverses, but the current always flows from the higher potential to the lower potential side. Electric power is transformed to other forms of energy when electric charges move through an electric potential difference, which occurs in electrical components in electric circuits. From the standpoint of electric power, components in an electric circuit can be divided into two categories. Some devices can be either a source or a load, depending on the voltage and current through them. For example, a rechargeable battery acts as a source when it provides power to a circuit, but as a load when it is connected to a battery charger and is being recharged, or a generator as a power source and a motor as a load. Since electric power can flow either into or out of a component, a convention is needed for which direction represents positive power flow. Electric power flowing out of a circuit into a component is arbitrarily defined to have a positive sign, while power flowing into a circuit from a component is defined to have a negative sign. Thus, passive components have positive power consumption, while power sources have negative power consumption. This is called the passive sign convention. In the case of resistive loads, Joule's law can be combined with Ohm's law to produce alternative expressions for the amount of power that is dissipated, where R is the electrical resistance. In alternating current circuits, energy storage elements such as inductance and capacitance may result in periodic reversals of the direction of energy flow. The portion of power flow that, averaged over a complete cycle of the AC waveform, results in net transfer of energy in one direction is known as real power. That portion of power flow due to stored energy, that returns to the source in each cycle, is known as reactive power. The real power P in watts consumed by a device is given by Where? Explanation. The relationship between real power, reactive power, and apparent power can be expressed by representing the quantities as vectors. Real power is represented as a horizontal vector and reactive power is represented as a vertical vector. The apparent power vector is the hypotenuse of a right triangle formed by connecting the real and reactive power vectors. This representation is often called the power triangle. Using the Pythagorean theorem, the relationship among real, reactive, and apparent power is: real and reactive powers can also be calculated directly from the apparent power, when the current and voltage are both sinusoids with a known phase angle theta between them. The ratio of real power to apparent power is called power factor and is a number always between 0 and 1. Where the currents and voltages have non-sinusoidal forms, power factor is generalized to include the effects of distortion. Electrical energy flows wherever electric and magnetic fields exist together and fluctuate in the same place. The simplest example of this is in electrical circuits, as the preceding section showed. In the general case, however, the simple equation P equals 4 must be replaced by a more complex calculation, the integral of the cross product of the electrical and magnetic field vectors over a specified area. Thus, the result is a scalar since it is the surface integral of the Poynting vector. The fundamental principles of much electricity generation were discovered during the 1820s and early 1830s by the British scientist Michael Faraday. His basic method is still used today. Electricity is generated by the movement of a loop of wire, or disc of copper between the poles of a magnet. For electric utilities, it is the first process in the delivery of electricity to consumers. The other processes, electricity transmission, distribution, and electrical power storage and recovery using pump storage methods are normally carried out by the electric power industry. Passive sign convention. Resistive circuits. Electricity is mostly generated at a power station by electromechanical generators, driven by heat engines heated by combustion, geothermal power, or nuclear fission. Other generators are driven by the kinetic energy of flowing water and wind. There are many other technologies that are used to generate electricity such as photovoltaic solar panels. Alternating current. Electromagnetic fields. Generation. Electric power industry. Use. A battery is a device consisting of one or more electrochemical cells that convert stored chemical energy into electrical energy. Since the invention of the first battery in 1800 by Alessandro Volta and especially since the technically improved Daniell cell in 1836, batteries have become a common power source for many household and industrial applications. According to a 2005 estimate, the worldwide battery industry generates $48 billion in sales each year, with 6% annual growth. There are two types of batteries: primary batteries, which are designed to be used once and discarded, and secondary batteries, which are designed to be recharged and used multiple times. Batteries come in many sizes, from miniature cells used to power hearing aids and wristwatches to battery banks the size of rooms that provide standby power for telephone exchanges and computer data centers. The electric power industry provides the production and delivery of power, in sufficient quantities to areas that need electricity, through a grid connection. The grid distributes electrical energy to customers. Electric power is generated by central power stations or by distributed generation. The electric power industry has gradually been trending towards deregulation, with emerging players offering consumers competition to the traditional public utility companies. Many households and businesses need access to electric power, especially in developed nations, the demand being scarcer in developing nations. Demand for electricity is derived from the requirement for electricity in order to operate domestic appliances, office equipment, industrial machinery, and provide sufficient energy for both domestic and commercial lighting, heating, cooking and industrial processes. Because of this aspect, the industry is viewed as part of the public utility infrastructure. Notes.